Alright, in this video, we are going to learn about condensation polymerization. And condensation polymerization, this is only for pure chem students or syllabus code number 6092. Okay, what exactly is condensation polymerization? Okay, condensation polymerization, right, is just basically the process where large number of repeating units okay so what do? They join together. Okay, hold on, I'm gonna explain in detail later, okay, with elimination of small molecules. I'm gonna go into the nitty-gritty details later. So this is basically it. So I'm gonna explain the first sentence one by one. So what do I mean by large number of repeating units? Let's call the large number of repeating units, let's call this n. So basically there are n repeating units. So let's say I give you a polymer. Let's say I give you addition polymerization as we learned earlier. So we know that only CC double bonds will happen, right, in addition polymerization. So this is known as ethene. Ethene has the formula of C2H4. And from here, what do we know? From here, we can say that this is polyethene. Okay, polyethene via breaking the CC double bond to CC single bond. And then we lay out here like this. N. So we don't know how many repeating units are there. So there can be many. It can be maybe starting from 1 all the way to maybe infinity. Who knows? Okay, so this is just a demo lah. Okay, so right now, what does the second sentence mean? Join together with elimination of molecules. Some examples are water and hydrogen chloride, HCl. So what are these? These two are in your condensation polymerization, these are your products. Okay, so for condensation polymerization, this is the important part. They will join together by eliminating molecules like your water and your HCl. And these are known as your products. What else? And you will need monomers. Monomers that have the same functional group on both ends. Alright, FG for short for functional group, okay? On both ends. The keyword on both ends. I want you to take note about this. It must have the same functional group on both ends. I'm going to explain further about what does this mean. So now this is just the definition. And this is the main part of condensation polymerization, where I'll write in purple here. We are going to learn about two types, polyamide and polyester. Okay? And polyester. Or polyester lah. Okay? So, polyamide. What is polyamide? So when you see amide, what will you think about? You'll think about amide linkage. Correct? What exactly is amide linkage? I'm going to share with you later. Okay, so how is polyamide formed? Polyamide is formed by a diamine plus a dicarboxylic acid or dicarboxyl. Okay, so amine is, what is amine? Amine is your NH2 group. Can understand? So diamine. Let's say I give you example of a diamine. Okay, so diamine. Let's say I give you this. This is, I don't know what is this. The box, right, just represents it is a certain compound. And I'm gonna explain to you in detail later. Okay, so basically, let's say I got diamine. So I got an N, a H, and a H. You see that? So this is your diamine. Okay, diamine in orange. Okay, I'm gonna erase this. I'm gonna write it in orange. Then dicarboxyl, I'll write in green, okay? NH2 group. This is important, And dicarboxyl. Remember, in carboxylic acids, after alcohols, you learn that carboxylic acids, they have the COOH group. You understand, Sorry, did I put it wrongly? I meant, no, correct. Okay, so this is the COOH group. Can I understand, So dicarboxyl. What does di mean? Di means, okay, mono, di, tri. Mono is, di is 2. Do you notice that there are 2 amine group? NH2. This is just the structural formula. Ultimately, it means NH2. Can I will annotate that later. So dicarboxyl, that means there are 2 carboxyl. So plus sign, dicarboxyl. So now maybe I draw a box, nothing. Why? Because the diamine and the dicarboxyl, they both have different compounds one. So it's like, oh, let's say the diamine. Why did I put one shaded box and one unshaded box? Oh, because, right, you know that diamine and dicarboxyl, they are made of different compounds. So that's why it's unshaded. So we're going to draw a dicarboxyl group here. Okay, hold on. I need more space. So I'll just erase. But about the box thing, right? It is just that it is like basically like belonging to its respective compounds. So do you notice that there are 2 carboxylic acids here? 2 carboxyl group. Can see, right? This one so far can understand or not? Okay, so di means 2 again, so we're just gonna circle it. Di is di 2. Okay, so in this case, right, we know that it will basically react to give you a polyamide. So you notice that, right, monomers that have the same functional group of both ends, I want you to think that monomers are products. No, monomers are reactants, not products. Your products will be your elimination of small molecules like water and HCl, and your molecules must be small. Okay, so from here, right, we know that this gives you polyamide. Polyamide is also known as your nylon. This is important, It's also known as nylon. Okay, so how do you draw the structure of nylon? Remember that you're going to remove your water, right? So when you remove water, I want you to know that you only remove these 2H. Why? Because the nitrogen is bonded to the hydrogen as well. And of course your OH as well to form water. So only remove these 2. Why? Because your carbon, because your oxygen, right? Why don't remove this one or this one? Because your hydrogen must bond to your nitrogen and your oxygen must bond to your carbon. So don't remove it. Just only remove those at the side. This is how I remember lah. Okay, so right now this will give us, I draw an arrow here. So this will give us we just copy and paste exactly. So now we have your NH, your box that is shaded, NH, now let's go, CO, okay, so basically this is how I would draw it lah. Okay, and then now maybe I will want to bracket this up and put an N here. And what's your byproduct? You always have a byproduct, Just saying, this is your byproducts. So you will have don't know how many water molecules, so it's just NH2O. This is your final answer. And where is the amide linkage? The amide linkage is here in purple. NHCO. So amide linkage is also known as, just remember, like NHCO. If you see NHCO like this, for me, I'll just draw it like that and it's good enough already lah. So don't make life so complicated. Make life easier lah. Okay, so we just do it like this. It's already 10 minutes. I'll stop the video here. Watch the next part on polyester.